Hello everyone, my name is Akshay and I am from ECE department 6th semester. Today I am here to present my seminar topic Stratolites, which means satellites in stratosphere. The contents which we are going to cover in this conversation are introduction about stratolites, existing technologies such as satellites, stratolites, construction and working of stratolites, stratolite versus satellites, advantages, disadvantages of stratolites, and overall conclusion of the presentation. Now, let us come to the stratolite. Stratolite is the combination of two words, stratosphere plus satellite, which means satellite in our own stratosphere. Now, let us come to the introduction part. Wireless communication is simply data communication without the use of landlines. This may involve cellular telephone, two-way radio, fixed wireless, broadband wireless, laser which is free space optics, or satellite communication systems. Mobile wireless technologies are going to act as glue towards bringing together the wired and wireless to share and distribute information seamlessly across each other's area of references. Since from the beginning of wireless communication, there have been a number of developments in each generation. Considering the future generation of wireless communication which we are using today, 4G, fourth generation, which we are using today to achieve the goals of true broadband cellular services, the system have to make the leap to a fourth generation, which is 4G network. 4G is intended to provide high speed, high capacity, low cost per bit IP based services. The goal is to have data rates up to 20 MB per second. Most probable, the 4G network would be a network which is a combination of different technologies such as 3G cellular network, wireless local area network which is LAN, current cellular networks. 4G cellular systems should not be high speed but also high capacity with low bit cost, high capacity and reasonable frequency bandwidth. The cell radius of the 4G cellular systems shall be decreased from that of present cellular systems. Now let us come to the existing technology which we always know are satellites. Now, what is satellite? Satellite is an artificial object which has been intentionally placed in higher orbits. Satellite communication is the backbone of wireless communication and GPS, which is global positioning system. Satellite in orbit of the planet cover huge footprint territories. Satellite comes in four types: geostationary, sun synchronous, geosynchronous and low earth orbit. Now let us come to the advantages of satellite communication. As we know today, satellite communication is the base of the communication and there are many advantages of it, like high bandwidth, coverage over a large geographical area, can be cheaper over long distances, ground station sites are easy to install and maintain, service from one single provider easy to obtain, and uniform service is available. Now let us discuss these advantages in details. It is used in wide variety of applications such as global mobile communications, provide business networks, long distance telephone transmissions, weather forecasting, radio/TV signal broadcasting, gathering intelligence in military, navigation of ships and aircrafts, connecting remote areas, television distributions, etc. Security in satellite transmission is usually provided by the coding and decoding equipments. Service from one single provider is easy to obtain and uniform service is available. Over long distances, it is cheaper. The laying and maintenance is easy and cheap in satellite communication, therefore it is best alternative. During critical conditions, each earth station may be removed relatively quickly from a location and reinstalled somewhere else. Ground station sites are easy to install and maintain. As we all know, if there are advantages, there are some of the drawbacks. Now let us come to the drawbacks of satellites. Two main drawbacks of satellites are: the first is signal latency, which can cause problems in establishing broadband links. Most telecommunication satellites are in geostationary orbit to remain above a certain point on Earth's surface. The orbit, however, is even. Users of a satellite voice links notice the delay, 22,240 miles above the Earth, which means that a signal going up to the satellite uplink and back to the Earth, which means downlink, travels nearby 45,000 miles, which equates to about a quarter of a second delay. The drawback is that satellites are in space, requiring expensive space launches, an additional level of regulation by national space authorities, and an orbital allotment via the International Telecommunication Union, which is ITU. Also, they include noise interference due to large distance between transmitter and receiver units. Now, let us come to our main topic, stratolites. A stratolite is similar to a satellite but is stationed in the stratosphere rather than on the orbit, as I told you earlier. Stratolite is a HAA high altitude airship which is positioned approximately 13 miles above the Earth, which provides the benefits of a satellite like remote sensing, navigation, and communication. Each stratolite will have clear line of sight communication, capability of an entire metropolitan area, as well as being able to provide coverage across major rural areas. The stratolite is designed to carry certain payloads into the stratosphere, determined by the requirements of the customer. A single unit could send broadband, mobile phone, and digital television and radio signal to a large area. The unmanned stratolite would be powered by solar cells and propelled by electric motors. Now, let us come to the construction work of the stratolite. Outer layer is made of spectra, is a fabric used in bulletproof vests, filled with a mixture of helium and air, consists of propeller, solar cells, regenerative fuel cells, helium gas bag transponder, hybrid electric motors. The starting satellite was 188 feet larger, 60 feet wider, and 42 feet height. It is provided with a new steering method which uses a hybrid electric system that drives large, slow turning propellers. This gives the airship leeward like agility by being able to move both up and down and side to side. The outside layer is made out of a high-tech material called spectra, a fabric used in bulletproof vests and parts of space shuttles. Spectra contains fiber 10 times as strong as steel of the same weight and has the unique feature of being easy to cut but virtually impossible to tear. The inside layer, made from a thin but strong polyester film called mylar, is fitted inside the envelope and filled with a mixture of helium and air, as helium is an inert gas and is therefore not flammable and not dangerous. With this design, the helium expands as the airship rises, forcing air out and lifting the airship. The cycle continues, allowing the airship to gain more and more altitude until the helium gas expands till the envelope completely. Because the force is so low inside the envelope, a puncture would only result in a very slow leak, taking a long time to totally deflate. Now let us come to the working. Inside is filled with helium gas, as it is inert gas, not flammable. The helium gas expands, pushing out air and lifting the airship. Uses solar cells sprayed on the surface to generate electricity. The generated electricity drives propellers that work with GPS technology to keep the satellite stationary. These are some two different pictures of satellite and stratolite. Now, satellite versus stratolite, or stratolite versus satellite. Stratolites are low cost, as satellites are high cost. Stratolite works in low altitude and satellite works on high altitude on the high orbit. Stratolite needs multi-launches and satellite needs only single launch. Stratolites are easily upgradable. On the other hand, satellites are not upgradable. Stratolites are latest technology and satellite are mature technology, which means it is older technology. Stratolites can be used for IP and CellTX, as on the other hand, satellites cannot be used for IP and CellTX both. Stratolites are faster to deploy. On the other hand, satellites are slower to deploy. Stratolites have higher bandwidth and multiple platforms. On the other hand, satellites are limited uplink and only have one platform. Now let us come to the advantages of the stratolites. It decreases signal latency, less expensive to launch, service an area of 300,000 square miles, two-way high-speed data communication, high-speed broadband access even in remote area. For a country, 2 stratolites are enough instead of thousands of towers. Stratolites will carry over 20,000 pounds of radars and other remote imaging equipment, navigational aids, and telecommunication relays. Stratolites are planned to remain on station for a year at a time and will cost a one-fifth as much as comparable to a satellite. Means stratolites are more comfortable and cheaper. Now let us come to the disadvantages of stratolites. They may lead to a traffic problems in stratosphere, would require efficient ground control and maintenance. So far, this technology remains non-commercialized and is in a prototype stage for further developments. This technology not come in the use yet, but it only is in a prototype stage for the further developments. Unlike with the satellite, a stratolite is at the mercy of the weather. Now let us come to the application of the stratolites. In environmental disasters, telecommunication breaks down within seconds. Reinstallation of the infrastructure takes weeks or months. The stratolites can be used as a floating mobile telecommunication station for all telecommunication purposes and the transmission of temporary data telecommunication and TV program as well as long-term missions over metropolitan cities. The Stratolite will allow subscribers to easily communicate in both directions using readily available wireless devices. In addition to voice and data, proposed telecommunication uses include cellular 3G or 4G mobiles, MMDS, paging, fixed wireless, telephony, HDTV, real-time surveillance and others. Application case Google's Project Loon. Now let us come to the conclusion of overall presentation or stratolites. Probably the most far out there concept in this roundup, stratolite is actually much closer to reality than what you may think. 1. The defects of stratolites have been overcome and become more reliable and then play a vital role in our future generation wireless communication. This is promising technology that would combine the best of satellite and wired internet, fast with low latency and hugely widespread, at least in theory. Now, the overall conclusion is that stratolites are the future generation wireless communication and stratolites are the future of wireless communication. Thank you and have a nice day ahead.